Good morning all and welcome back to our continued series of our CPD webinars, this time all about dampness within buildings. I'm your host, Andy Ferguson. Joining me as always is James Berry, and taking us on this dampness journey today is PCO's very own CEO, Steve Hodgson, who has just literally left the screen somewhere. Steve, if you're in that room, hello to you, wherever you are.
I'm in the room.
If you are one of our regular listeners, then a big thank you again for kind of tuning back in with us. If you're one of our new listeners jumping on board, well, a big welcome to you. Hopefully you get a lot of kind of valued learning from today. I just also want to say a very special big welcome to everyone from around the world that's actually joining us. We've got a few international visitors from what I can actually see. We've got a few folk joining us from Australia, France and Germany, and certainly others from other countries as well. Guys, just we've got a few minutes before we actually start the main presentation. I just want to kind of walk you through some housekeeping sort of stuff. So first things first, if you want to engage with us, if you want to kind of chat with us, even if you just want to say a wee quick hello and good morning to us, several ways in which you can do this. First things first, if you're on a desktop computer, you have the chat functionality, which depending on your settings will either be on the left or the right on your screen. There's a little comment box with the text says type your comment. Feel free just to kind of rattle away anything you want to say there. A wee good morning. I can see that there's already people on there saying good morning, so good morning to you all. If you're on a mobile device, similar as well, your chat facility is literally just below the screen. You just need to pull up a little bit depending on your screen size. Again, you'll see the comments button within there. Just feel free to just stick in anything you want to say. There is alternative ways in which you can also fire in any questions over the course of the webinar, and we do encourage you that at any point during the webinar to feel free to use that chat or the alternative means. You can also email your questions. If you want to email your questions directly to james@property-care.org, that's james@property-care.org. Or if you are so socially savvy, you can go via our social channels. If you want to either visit us via LinkedIn, Twitter, or Facebook, simply just use the search functionality, type in Property Care Association. We should pop up. And as always, if we don't pop up, I would be keen to hear, so please do let me know. Now, guys, we've got a lot of people joining us this morning. There's a lot that's just kind of joined us over the last couple of minutes. I just want to say as well, I mean, as you are aware, with us all kind of working at home with COVID-19, there's a real strong pull on the internet at the moment in time. It does happen from time to time where you might lose connectivity. If that happens over the course of the webinar, there will be a button that will display pretty much in where the presentation is, and it will say reconnect. Simply just by hitting that button, you will just reconnect straight into the webinar. Crossing fingers for you, though, that doesn't actually happen. So we've got still got a couple of minutes waiting for people to join us. Just to kind of give you a wee heads up and stuff that's actually coming up, guys, for future webinars. Next week, we do have our continuing series of webinars still going on. It's all about waterproofing, insurance, design with confidence. We also have the following week on the 21st, we have the next of our invasive weed-based webinars coming up. Under the Radar, Bamboo and Budlayer, being headed up by Jim Glacier. And for all those that are our PCA members, you also have every Tuesday, your Tune-In Tuesday. Now, this is, again, your broadcast, your show, your forum for you to actually come on, ask the questions that are kind of bothering you. It's our platform as well, on which Steve will give you an update for the course of the week and what's been happening. And anything we can help you with within that forum, we will try to do so. So, guys, I can see we've had another big chunk of individuals that have actually joined us. A big good morning to you all. We are just about to start. A big welcome to you to our latest live webinar, all about dampness within buildings. Just before I start, for everyone that was just new, and I apologise to the individuals that have already heard this, but very quickly, if you want to pose any questions over the course of the webinar, if you want to chat to us, there is the chat facility on the desktop. It's on the left or the right hand side. On a mobile, you just need to push it up and you'll see it in there. And lastly, if you don't want to use the chat facility, you can email any kind of questions you've got. Feel free to just email my colleague James, who's just on the screen there or there, depending on your setting. It's just simply james@property-care.org. So guys, I can see we are very nicely at the 9 o'clock stage. I suppose it's probably a good time for me now to pass you over to our main speaker, Steve. So I suppose, Steve, from kind of moisture meter diagnostics, the pros and cons to different kinds of moisture management, and even a few myth busts, which I know you're going to be looking at as well. I suppose it's up to you to take us down this journey of dampness within buildings. So,
well, Andy, it's not
over to you.
It's not a dark journey at all. It's going to be an enlightening journey, but I'm not sure about a dark journey. Well, so good morning, everyone, and welcome. Yeah, my name's Steve Hodgson. I'm the CEO at the Property Care Association. I've kind of had a kind of a long career in everything to do with dampness and moisture in buildings. That started literally on a building site, working as a labourer when I was 18, and after going to building college and doing various other bits and pieces, I ended up working in a preservation company that saw me through into the association. And I've been here for now a few years, and the CEO for just over 10 now. My background is very much practical. I've spent lots of time taking buildings apart and putting them back together again, and sorting out not only my own problems but lots of other people's problems when things go wrong. So yeah, I'm most certainly a practical person, and I take a practical and pragmatic view of these things rather than a purely academic one. Though over the last few years, links with University College London and employing our own research scientists has certainly given me an insight into how the academic view of dampness works. So this is going to be, it's not really a presentation about remediation and about remedies. It's much more about how we think of damp and how we recognize it and how we diagnose it. And it's not going to be a step-by-step guide to how to use a moisture meter either. It's going to be a conversation really about dampness and the kind of the more broad thoughts around how we manage it. So let's start right down. The other thing I've got is a few slides today that don't make me particularly proud. And this is the first one. This is a house in Derby where I used to work, near where I used to work at the British Pest Control Association. You can see a beautiful slab with a blue brick damp proof course. It's probably a remedial one. And then if you look very carefully, you'll see damp proofing holes above it. And you'll notice that that's about 2.5 foot up from the internal timber floor level. You know it's got a timber floor because there's a cellar underneath it. These are the things that do not make us proud. And as a responsible preservation industry that's built on skill, built on knowledge, these are the things that give us a bad reputation, or have given us a bad reputation, and the sorts of things that we're working very hard to put right. So not stuff we condone. So what is damp? Well, all construction materials, all solid construction materials have a moisture content. Some plastics probably don't, but most porous materials gathered from nature and reformed as construction materials, whether it's timber, bricks, even concrete, has a moisture content, and it will be in equilibrium with the moisture in the air and with its environment. So everything has a moisture content, but it's not all damp. So how do we distinguish what's damp? Well, I'm going to read a few bits off slides. I don't do that very often, but solid build materials are only damp when there is an excess of unbound or free water. So if you get moisture that enters the building through various sources, we'll look at some of those in a minute, it's only when that water can move around in the structure, when it becomes either a transport mechanism for other things inside the wall. It affects the thermal performance because the air is displaced by water, and the water conducts energy far more efficiently than the air, or when it can act as a medium for the breakdown of stuff. So it's where animals and plants and fungi can start to use it to break down materials. They use it, moisture contents go up, and they can eat it essentially. So it's the free water, it's the excess water that is problematic. And so what are the consequences of free or excessive water? Well, we know that timber in contact with damp masonry is susceptible to decay. It absorbs water from the environment, from the timber, it transfers into it, and it rots. Now, insect infestation. So the picture of the joist on the photograph shows you a joist. It has decay, it has some wet rot in it. The wall plate has some wet rot in it, but there's also some woodworms, some anobium in it. And the anobids need a moisture content, an elevated moisture content to get going. And it allows insects to munge through the sapwood of that piece of pine. It'll also allow mold growth. We talked about the reduction in thermal performance. The water, the free water, will also act as a mechanism to transport salts, and that can break down both timber and masonry structures through process of chemical attack, but also through the expansion of the salt crystals as they turn from a liquid into a solid, breaking down the surface of the stone. If you can see just in the backwash of this slide, there's a piece of sandstone wall with salts appearing at the surface, in part because it was pointed with sand cement when the wall was very wet, and the salts are now coming out through the stonework. High moisture contents in masonry structures also causes freeze thaw in cold climates in the winter, and that's something actually we're seeing a little bit more of recently as we started to apply insulation to the inside of buildings. It's making the walls colder, and actually it's causing more freeze thaw problems on buildings where they've had internal wall insulation. One of those odd, unexpected consequences of that. And we also see when things get wet, the debonding of structures. So plywoods come apart and other things start to break down. So where does this water come from? And this is where we make moisture diagnostics actually really simple. It's very route one is this presentation. It's either water that's outside the building that wants to get through the envelope and get in. So essentially rainwater. Water that has originated from the sky, falls onto the roof, hits the walls, goes into the ground, goes into the drainage system or into the soil, and hopefully drains away. Well, unfortunately, if we build boxes and we put them into this damp soil under these wet skies, at some point, if we're not very careful, water tries to get in. And that water, and we know, causes problems. The other source of water is the water that's generated inside the building, that essentially wants to get back out again. And the main issue here, and there are a couple of others, we'll look at them in a moment, is atmospheric moisture caused by occupation. So where does the water come from? So these are some of the common sort of defects that we see that are the instigators of lots of issues. The first slide, right in the middle, somebody said on the LinkedIn channel, are we going to learn about whether true rising damp exists? If there is water in the ground and there is nothing to prevent it coming up a porous structure, then yes, water will rise. And if you like, that's rising dampness. It doesn't really matter what the cause of the water is at the base of the wall. If it rises, it's rising damp. And there are ways to resolve issues with rising damp by removing the water from the ground. However, they're often a lot more expensive and complicated than some of the more obvious solutions that our industry have been providing for years. Top left, you'll see another one of those photographs that I'm not particularly proud of. As the head of a trade association, that looks after people that install damp-proof courses, somebody started to stick a damp-proof course in a blue brick header course in a wall that's clearly completely and utterly, well, unsuitable for its purpose, needs pointed, needs sorted out, but somebody still tried to stick a damp-proof course in. So you've got drainage issues, you've got rainwater goods issues, you've got roof leaks, flooding is something that is big in the news at the moment. All these things cause water to get into the structure and get into the masonry walls where it's held, where it can then move around, where it can cause problems. Bottom right is a photograph that I took quite recently out on the East Coast. There is a bit of sand and cement pointing on around the corner, but actually most of that isn't caused by poor maintenance. It's actually as a result of really, really exposed conditions and poor selection of building materials by the original builders. So water from inside, and how does that manifest itself? Well, plumbing leaks are common. They can often sometimes go unresolved for a very long time and cause massive problems. We see huge dry rot issues and wet rot issues caused with plumbing leaks. We of course see lots of debonding and damage to finishes as a result of plumbing leaks. But we also see things like the bottom left-hand photograph is a new roof with huge amounts of water on the inside of the sarking. You see that and you often wonder what's going on. Is there insufficient ventilation in the roof? Is there something going on where huge amounts of water are being generated? And just actually, that's the issue. It's not where the water has been generated. It's often in new buildings where water has been built into the structure and takes a long time for it to come out. And usually for the first 12 to 18 months, if the building hasn't been dried down properly, and particularly when the occupants are moved in quickly after the construction phase is complete, you get a lot of water inside the building that then wants to get out, and it manifests itself in condensation in all sorts of horrible places. Top right hand slide is if you look carefully, you'll see decay along the length of that joist away from its contact point with masonry. And that again is caused by high atmospheric moisture conditions in the subfloor void that have elevated the moisture content to a point where decay can take place within the section of the timber. Now, you would say that if that moisture is being generated from the ground, then it's moisture from the ground coming into the building. However, there's quite a lot of evidence to suggest that a lot of the moisture in subfloor voids can be generated or is generated by occupation and is driven through into the lower vapor pressures of the subfloor void, where it can then wet up the timbers. And the bottom right hand photograph is a great picture of mold growth it's basically as a result of internal moisture imbalances. And we're going to talk about internal moisture imbalances a little bit more as we go on. So a few years ago, we were looking to start a debate with a number of people around getting a research project going. And I was challenged by a guy called Neil May, who unfortunately died a couple of years ago, who founded the UK Centre for Moisture in Buildings. He said, well, why don't you actually think about understanding what is an acceptable level of moisture in buildings? There's lots of debate about, how moisture is diagnosed, how moisture is then dealt with. The term breathability is one that makes my hair curl and doesn't really mean anything. But there's lots of conversations about these things where people are in disagreement. So why don't you actually concentrate on looking at a project where you understand and define what an acceptable level of moisture is? And so the next few slides is really some of the thoughts that have come from that discovery, from that journey of thought and discovery. That project converted into a 2.5 year knowledge transfer partnership with University College London, and that has resulted in some quite interesting findings, which I'll pick up on later in this presentation. So, if there's sufficient water to cause any of these things, so mold growth, conditions for insects, deterioration of finishes, liquid water in the surface, staining, salt damage, timber decay, distorted timbers, all of those things, all the collapse of structures, By collapse, I don't mean catastrophic collapse every time. I mean things like fiber boards, plaster boards that actually disintegrate because the moisture contents are so high. All of those things actually define a damp problem. If they are there, there is free water and there is most certainly an issue. If there wasn't, the building would be in equilibrium, these things wouldn't break down. The other thing that's really important, I put it at the bottom, is that dampness makes people fed up. It's unpleasant. You don't want it in your house. So if you have distorted or falling off plaster, if you have issues of that nature in the house that you're looking after, that you're the custodian of, that is your pride and joy, that's your biggest investment, and you have something that looks damp, then you don't want it. It makes you unhappy. There's also some suggestions that, of course, that it can make you ill too. And there is a debate about whether the biggest issue is about making your mental health and how it makes you feel and how it depresses one, or whether it's actually the effects on your the physiology from the dampness itself. We're used to living in relatively damp climates, but actually living in a damp house is just miserable. So let's move on. So let's think now from a scientific point of view, rather than the visual point of view, what the issues are, or where the critical thresholds for moisture issues might be. And here are three gentlemen that have influenced me over the years. Graham Coleman, a friend and mentor. Chris Coggins, bottom left, who was my ex-boss, but a mycologist and somebody that knew more about dry rot than anybody I've ever met. Brian Ridout, who basically knows a great deal about lots of stuff and has written lots of books. But some of these are taken from their quotes. Moisture contents of less than 20% provide what is described as immunity from fungal decay. I wouldn't say they were completely immune, but generally timber below 20% moisture content is kind of safe. It won't rot. However, you need to get it below 15% to stop anobids. Anobids are woodworms and death watch beetles and the common forms of wood destroying insects that we see in the UK. But that's common for most timber destroying insects too. Things like wood boring weevil and lictus, they still like elevated moisture contents as well. But the water masonry thing is the big question. So there are lots of numbers kicking around about what constitutes damp masonry. But what I've kind of done and looked at on my journey of, if you like, discovery or rediscovery of these subjects is that actually you can have moisture contents of 1% and you get things that are incredibly wet. So how does that work? So let's take a panel of brickwork. It's a section of 4 different types of brickwork there. The one on the left is a hard blue brick, fire bricks, engineering bricks, whatever you want to call them. The second panel is a type of brickwork that's incredibly familiar to me. It's a section of brickwork from a terraced house in North Leeds. They're Normanton Commons with very thin joints, usually black ash mortar with a white line pointing across the front. Really tight, really well built, really good external skins anyway. The next is a panel of softer brickwork, and the one on the right is a mud brick. Now, BRE sort of indicate in their guidance in BRE 245 that if you have a moisture content above 5%, you can consider a masonry structure wet. And below 5%, you're probably okay. And there's not very much description in that. However, I would say, and I would assert that if you had 5% moisture content in the brick with the blue brick on the left-hand side, that wall would be saturated. Those bricks are incapable of containing 5% by weight or volume of water because there simply isn't enough room inside the material to get up to 5%. At 5%, the Normantons, the Leeds bricks, they too would be absolutely saturated. I would say that the next panel at 5%, they're kind of about, well, might even be in equilibrium if there's a bit of salt kicking about. And in the right-hand panel, 5%, those mud bricks would be dry. So the point I've tried to make in the words underneath is without a reference to density, porosity, and equilibrium moisture content for every product that we look at, how do we really understand the level of wetness that there is in any given construction material? And if we detect free water, is that always going to be a problem? How do we detect that free water? How do we know? And that really is the trick of the surveyor, if you like. Now, here's a slide of a selection of moisture metering things that I have found kicking around the office and stuck on a table to take a photograph of. The question is, are they any good? Well, some of those things that lots of people will be screaming at the screen saying, well, they're all for atmospheric moisture, and they are much more scientific than the conductivity meters, and there's 3 of them, I think, sat in that photo, or 4 of them that do some sort of conductivity metering and gravimetric metering. Are they any good? Do they give you an indication of what? No. Do they tell you the moisture content of samples? Well, to be fair, in timber, they're not bad. They're relatively accurate. They're within 1 or 2 percentage points. But in masonry, they can't possibly tell you the amount of free water that's available in a sample. Question is, does it matter? Does it really matter that you know? Because what you are trying to do in using these instruments is understand where there are anomalies, where there are changes. So if you're using one of these pieces of kit and you're discovering on the right-hand side, or the left-hand side, for example, that you're using the capacitance meter on an old MMS meter, and it's saying, it's giving you a reading of 1,000. Now, we don't know what 1,000 is. We don't know what they are reading a number of thousands. It's just an arbitrary measurement. But if you've been sweeping across the wall and it's been saying it's 250, and all of a sudden you find a bit that says that it's 1,000, that gives you a really strong guide to where to look, to start using your brain, your instincts as a surveyor, your skills, to start to understand why you've got that anomaly. The moisture meter is a great guide, and the conductivity meter is a fantastic instrument at telling you when something is dry. It's lousy in masonry for telling you how wet it is, but it's great for telling you that the things are actually not worth worrying about, but actually, great, again, for giving you an indication. Now, the other 2 things I've got shown a slide of here is a speedy meter in the middle. Speedy meters are quite useful if you want to defend claims, or if you're using the thing to find out how much moisture there is in aggregates, which was what it was designed for. But the fact is that a speedy meter, unless you understand it, unless you understand that it gives you the total water content of the sample and not simply the free water content of the sample, can be quite a dangerous tool. Because without understanding what the if you like, entrained water content is, you don't know by how much the sample is excessively wet. And so speedy meters kind of can be useful if you're doing moisture profiling and you're looking at differences and you want to do that relatively accurately, but actually to tell you what the free moisture content and how damp, excessively damp a wall is, beware. The only way to do it is to use gravimetric testing. And gravimetric testing is something that's done in the lab, away from site, usually done again with profiles, but that will give you both the weight of the content of a dry sample. It will give you the air dry moisture reading, and it will also let you know what the excess element, the free moisture content of the sample is. And really, gravimetric testing is the only way to go if you want that information. Now, I'm going to bring it right back to the simple stuff again. So, the determination of a damp problem. For me, it's as simple as this. Is what you're looking at causing a problem? If it's causing a problem, then it is a problem, and it needs measures to reduce or to prevent or to eliminate that problem. Is it what you're seeing likely to cause a problem? Does it have the potential to cause harm? And if it does, then actually engineering solutions or remediation is necessary to prevent further deterioration, to prevent problems from happening. And the third thing, which is just as important, is it a problem for the occupant? Because if it is a problem for the occupant, even though, and there is some debate, and I agree with the debate about historic buildings and whether some historic buildings have a degree of free water and always have had from the point they were constructed, and they manage that and they work with it well. And actually, it's probably been damp from 3 years after it was built in 1750, but a new owner comes in, somebody comes in and they want to turn that room into a dry, habitable, lovely place, then they are going to do that. And actually, it's our job not to tell them, actually, you've got to live with dampness, but we've got to work with them to deliver then a sympathetic and does less harm solution to that damp problem. It is no good for us to take the moral high ground and say, you can't do that to your home, because they will anyway. Now, one of the photographs here is, I pinched this from Damp Sam. I don't know whether you're on Damp Sam, but you'll recognize your own photograph of it if it is. Now, this I used to illustrate an issue, and I'm going to build a bit of a scenario around the chimney breast picture photograph. There is no current defect with that house. There is no water getting in at the roof. The flue has now been cleared, so there's ventilation up the old flue. In fact, the fireplace will work if you light a fire in it. There is no ongoing water ingress problem there. It's a lime plaster on the wall, and it's completely goosed with that big, massive, horrible, salty stain that's on the wall. What do you do? Now, there are a number of options. You know, the purist would say hack it off and put lime on it. The builder who looks at that will probably come and hack it off and put gypsum-based plasters back on it. One of my members may well come along and say, well, you've got a number of options. You can either hack that off and put a sealant behind it and then plaster it up with a lightweight plaster. You can put a lime on it if you want. That comes with a real big risk. Or you can dry line it. Now, to me, there are no wrong solutions in that. As long as you tell the client, as long as you tell the owner what all the risks are associated with each of those interventions, because there are risks with all of them. If the roof leaks again and you dry line it, you'll never see it. And so what's the implications of hidden moisture in a chimney breast like that, where you have timbers at the ceiling and timbers at the floor? If you cover it in sand or cement, with a waterproofing agent or an anti-sulfate agent, yes, all right, you're boxing it in. Is there an issue with that? Well, maybe. I don't think there's going to be much by way of moisture transfer. If you put something like lime back on the wall, it will undoubtedly stain through again, and they will be doing that job, or they'll be replacing that plaster again in 3 months. So to me, there is no absolute route one thou shalt. And again, this presentation is not necessarily about remediation, but it was worthwhile just picking up on that photograph and saying, what do you do? How do you think about the remedies there? And actually, it's a good illustration of, it doesn't matter which way you go to recommend remediation, there will always be an alternative view. So, knowing the precise moisture content of a solid material, is it always critical? No. In my view, it isn't. Actually, understanding the mechanisms by how that water got there, and having the skill, the knowledge, the expertise, and being bothered to find out how that water got there, understand what mechanisms are at play, what's at risk, is far, far, far more important to me than establishing the exact volume of water in any particular sample. Just understanding that there is something going wrong, understanding that there is a process that can be followed back and that can then be understood and rectified and remedied. I don't think that in the vast majority of cases where we discover dampness or we discover the risk of dampness, that understanding precise moisture content is necessary. This brings us then back onto the use of those pieces of equipment that are derided by quite a lot of people. You know, they don't give you a precise, so what? What they've done is allow you to identify the scope and the extent find it in the first place often, and then act to understand it further. As I say, far more important to understand the process than it is to understand its presence and the process than it is to understand the precise moisture content. There are some exceptions. When you're drying a building down, and these are photographs, a couple of photographs taken after the floods in Hull a couple of years ago, when a friend and colleague of mine, Dave Cook, invited me along to have a look at some properties that had been devastated by the floods that affected Humberside, East. No, it wasn't Humberside. He'll kick me for that. East Yorkshire and Lincolnshire, 10 years or so ago. It's very important when you're drying stuff out post flood or post water leak sometimes to understand precisely what the moisture contents are. And that is because you're going to reinstate. And if you're going to reinstate with stuff that are sensitive to moisture, that can be compromised by applying them to walls that aren't thoroughly dry, then you've got an issue. It's also important to understand precise moisture content when you're scheduling replacement of moisture sensitive elements, such as timbers and this sort of stuff. It's also particularly important where you're going to create closed voids. So areas behind timber frames, for example, you want to know that actually you've got a relatively dry environment behind there, because if you enclose it and you get this issue with cycling of water with heating and cooling, then that can be a problem, because that liberates free water in a way that can be used then for biodegradation of vulnerable structures. And where it's also incredibly important is when you're looking at preserving heritage assets. So curating buildings and ensuring that they're there for future generations, a real detailed understanding of moisture contents and an ongoing understanding of the changes in those moisture contents can be absolutely critical to prevent fungal decay and insect attack and the degradation of buildings. It's also very, very useful when you're trying to understand your and working in your maintenance elements. So if you detect spikes in moisture content, you can act on that very quickly before it causes harm. So it's not to say that understanding the detail of moisture content is never important. What I'm trying to impress on you is that actually in the more normal domestic realms of damp diagnostics and understanding buildings, then it's very uncommon for you to absolutely need to know the moisture content. And even if you do, you need then to be able to understand what you've learned. Now, I'm conscious of the time, so I'm going to keep cracking on. Now, let's leave masonry and solid building materials behind, and let's look for a few minutes at the critical thresholds for atmospheric moisture. Again, some of the people that I absolutely look up to in respect to this field of science and construction understanding. Graham, again, who inspired me and others to look at this and has taught and mentored a lot of us and still provides training at the PCA now on both dampness in buildings and on condensation. Dr. Fernando, who is now a fellow of University in Chile, and my friend and colleague Paula, who is currently employed by the PCA as our material scientist and is working on atmospheric moisture. In fact, she's at the moment probably scratching away, putting another bid in for funding to do a research project on what's it on this time? Atmospheric pollutants, and as they relate, where we've done a lot of work around moisture, it fits quite nicely. So we've spent a long time looking at atmospheric moisture in great detail, all funded, I have to say, by PCA members and the funds they generate. So again, we'll come back to what's an acceptable level of atmospheric moisture in a building. Well, the jury's out. There are an awful lot of stuff in the written literature, and it goes anywhere between 50 and 80%. As an ambient atmospheric moisture content, as a relative humidity. But when you come and look at most of the kind of government standards and one thing and another, it's around 60%, puts you in what is generally considered a safe condition, where you're not going to get massive problems with mold growth, and you're going to have a healthy and comfortable living environment. Moisture activity at about 80%. Now, for those, lots of you will know what the difference between RH and moisture activity is. RH is usually measured in the middle of the room, and will be the kind of ambient air moisture content, relates to the ambient air moisture content. The moisture activity is essentially the relative humidity right at the interface between the thermal elements, so the wall and the air. And because the wall is usually colder than the air that it contains, then actually you'll have a slightly different moisture content, relative humidity at that interface. And that's important because that's the bit that defines the point at where mold can grow. So it is slightly higher, but essentially, you know, we have these two numbers. So moisture activity at 8%, RH at 60, and even at 80%, quite a lot of molds will grow quite happily, but they take a while to kick off. So we then on to trying to understand imbalance and in buildings, and we understand that actually relative humidity and indoor air moisture content is a balance. It's a balance between the amount of moisture that's produced, the ventilation that's provided to the building, so its ability to exchange that damp air with cold, usually cooler, drier air from outside. It's about energy input and how much heat you put in, because relative humidity is absolutely related to temperature. And it's all about the thermal performance of the building. And yes, that is a fan unit installed inside a shower unit above a bath. Probably the worst installation I've ever seen. And the house on the right is a great photograph showing thermal performance. It's a tin house. It's basically a steel framed house with a steel external cladding. It's got terraline sprayed on it, but yes, that is rust leaking out of the house. And the photograph in the background is a fantastic photograph of dry rot that was sent to me last year by Adrian Dawson. So thank you, Adi, for that. Now, what we have looked at extensively for the last few years to try and understand is what we should be looking to understand imbalance and moisture imbalance in buildings. What are the causes of moisture of mold? What are the things that have put a building out of balance? And what we've recognized is that, and what we've seen and what we've been able to work around, is that actually all of those four elements that we talked about on the previous slide, if any one of them slips too far out of balance, then the other three can't make it up. And actually what you can often do is have very small amounts of alteration, very small amounts of manipulation on either the heat, the ventilation, the amount of production, etc. And actually it brings it back into balance. And so we've, over the last, as I say, a couple of years, done a lot of research into this. We've now got to the point where we've done our proof of concept, but we are in the process of developing, and that will hopefully be available for PCA members and other surveyors, a diagnostic tool that can be left in a property for a couple of weeks. And it's not something that can be done instantly in a snapshot, but then we'll understand what's going on in that building. It will actually quantify and diagnose imbalance, and it will also direct rectification works in a scientific way that will bring that property back into balance and therefore prevent or reduce massively the chances of future mold growth. So the science of diagnosing atmospheric moisture is far more about understanding in detail rather than, as it is in masonry, seeing a problem and then trying to understand the mechanism. You know what the mechanism is with mold. What you have to then, what's tricky is actually recognizing and quantifying the amount of imbalance that's taken place, understanding why that imbalance is there, and then providing the solutions. So really, to conclude that section, moisture management is as difficult and complicated as we want to make it. It can be very complicated, and it's a science, it's an art, it's something that has intrigued me all of my career, and I don't feel as though I know the half of it. There's a huge amount still to understand, but the basic principles are straightforward. We can spend a long time establishing moisture contents in buildings that we then pretend to understand, but actually don't get us any further forward. A client, a homeowner, generally doesn't care how much moisture there is. What they care about is how they rectify and how they fix it and how they don't have a problem and how they live a quiet and happy life. A detailed knowledge of construction is priceless if you're doing dampness diagnostics, because you have to understand those mechanisms, those how things interrelate and how they link together and how moisture moves through structures. In my experience, the best surveyors are tenacious, they're interested, and they like what they're doing. They want to lift the board, they want to look behind, they want to get into things. The other thing that I think it's important to point out is that moisture diagnostics are not always possible in one hit. They can be a stage process. You can have many more than one things happening at once. And so sometimes to understand that, you have to unravel it, and that may well take time. And that brings us on to, the fact that there may often be more than one fix. And so, thinking about all of the things all at once sometimes doesn't work, sometimes it does, but yeah. And in my opinion, it's very important that we as an industry, and we're talking about the specialist preservation sector, but actually as surveyors can say sometimes that we don't know, and that we know why we don't know, and that there's an opportunity to do further diagnostics, to do further opening up, so we do know, but don't guess. That leads to problems and bad reputations and issues. And it's good to say that, and admit we don't have all the answers, but we never stop learning. Now, I know that some of the people wanted to know a little bit about the methodology that we have put together in partnership with Historic England and with the Royal Institution of Chartered Surveyors. Here's a document. There's a link to it underneath. I'll talk about it very, very quickly. There is a caveat on the front that says it's a draft document. The current document on our website is not a draft document. It is finished. The only reason it has draft on it is because we would have to take the RICS's logo off if we take the caveat off. RICS have a lot of work to do, and they realize that they move quite slowly, and great organization, but they realize that if they totally endorse it, then their surveyors will be measured against this quite quickly, and their solicitors, and quite rightly, are quite nervous about it. So for now, that caveat sits at the bottom of the document and says that we're all happy with it, but actually we're not completely aligned with it yet. And so read the document for what it is. Now the document is reasonably easily set out. Here's a picture of some rising damp. I know the source of moisture. Nice picture, but there you go. So one of the things that the new methodology talks about is about understanding context, and it's something that we've been really quite thoughtful about. Context is not just about how the building sits in the street or how the architecture sits in the environment. It's about the little things too. It's about a skirting board or a dado rail, or it's about the way that the building is put together, its history of the building. And actually, it's a good thing that we're now thinking about the context of some of that stuff. What you will notice if you download and read the document is it doesn't talk about silly things like breathability. It talks about wetting and drying. It talks about the material's ability and understanding the ability, material's ability to get wet and dry out. It talks about cycling water. It talks about good surveying practice. It talks about a thoughtful and considered route to remediation. All things that the association has condoned and supports and has always supported. But it's great that we've now got this document that is a shared document between those three organizations. We've all come together. We've all stood behind it. So what are we doing with it? The association is now working to be compliant, and we're committed to the adoption of the methodology over the next 12 months. The COVID-19 thing has certainly thrown a few spanners in a few works, but we're still basically working to become aligned with all our members to this methodology by the end of the year. Since publication, we've now got a whole bunch of other people that have now come out and said that they support the principle of the document, and we're very, very welcome to have those people support it. What we do hope is that they will all use it as their procurement standard as well. So what we're doing at the association for our members is we're developing courses, we've got tutorials and webinars. We've got we're doing stuff at compliance audits, and all our members are audited at least twice a year. We communicate with them weekly, so we have a good open line of communication to promote the methodology. We don't have very much to do to change either our association qualifications or training, because actually they're very, very broadly aligned anyway. But there are some certain things to do. And what we're doing for others and other interested parties is things like this. So we've got some short duration CPDs planned. We've got some tutorials. I've got some guest speeches, some lectures that were planned. Don't know whether they're going to happen in the autumn or not. But we're also going to provide some guidance and some other stuff as well through the year. So watch this space for that. So that's me. Thank you very, very, very much for listening. It's been a blast. Here's one of my other favourite damp proofing pictures. This is a property up in North Yorkshire, and out on a walk I noticed a DPC had been installed at window level. So I climbed up the outside of the building to point it out. Not our proudest moment. These are the sins of our fathers, not the sins of us now. So please, when you see inappropriate things like that, do not consider them things of the now. We hate them as much as everybody else. So thank you all for being on this morning. I guess I'll field some questions, James, if you have them.
Yeah, absolutely. We've had quite a few come in. So if you've got any more, still keep firing them in. I'm going to clump a few together here because there's been a few on sort of a similar theme. And I've been around sort of measuring actual moisture content of air as opposed to using relative humidity, how you do it and why you do it.
Quite frankly, I don't. I'm not sure that there is a massive need. You can do, and it's very scientific and very lovely to do so. But as far as our work has been concerned, it really has concentrated on that balance between all the competing factors, because the total moisture content of the air, if you have a very warm and very effective outer skin, is a building can live with quite a lot of atmospheric moisture. If it never finds dew point, it's never a problem. So we've been looking really in detail at that balance issue and understanding all those four elements, understanding the thermal performance of the fabric, the airflows, the production, and all of those elements together, rather than actually being concerned about total moisture content. Total moisture content is kind of one of those things. It's like understanding the amount of total water in a construction product. Is it that important in the stuff that we're doing in occupied buildings? It's not that important for us, though I would defer to my extremely learned academic colleague Paula to talk to you in more detail about total moisture content.
One from Harry Bowden here, and you did sort of touch on this, but I think it's well worth going over again. Is it okay for a surveyor to say they don't know?
Yes, of course it is. In the same way as you wouldn't want to go to the doctors and tell the doctor, say, well, I'm not thinking his head, I'm not really sure what's wrong, but I'll give him some pills and sod him off, obviously, and send him home. Not actually sure about the diagnosis. You'd want that doctor to send you for further tests. You'd want that doctor to actually go through a full diagnostic process to get to the end. And so it's the same to some degree with moisture diagnostics. If you don't know and the answers aren't clear, it's not that you can't find out and you can't be sure of what's going on, but at the time when you've only got a limited period of time and only limited permissions for opening up, for example, don't guess at an outcome. If you don't know, explain why you don't know. Explain to your client what has to happen now for you to get a full understanding of the picture. It's absolutely fine to say you don't know, but say so from an educated, informed position, not from ignorance or laziness.
One just come in about the you alluded to issues with internal wall insulation and in the wall, and they've asked for sort of a bit more elaboration on and how that causes issues. Internal
wall insulation is I have to be very careful because it's a huge issue and it's a huge subject in itself. And if I give an incomplete answer, what will happen is that somebody will jump on it and say, well, you know, you're wrong. Well done IW internal wall insulation can be absolutely fantastic and work brilliantly. My issue, however, is that I haven't yet seen one done without an issue, because doing internal wall insulation and doing it properly and comprehensively is expensive and very involved. So where you get problems or potential problems is in incompleteness. So it should be monolithic. It should be all the way up everything. Otherwise you get cold spots. And those cold spots can be problems in themselves. But if you think about the issues, even with trying to put insulation on the warm side of a wall, and particularly if that insulation is very, very permeable or vapor permeable, so the vapor can go through the insulation and then it condenses on what is now a particularly cold surface behind the internal wall insulation, then free water can build up. Now, there's lots of conversations about moisture buffering and one thing and another, but actually it does happen. And there are academic papers out there that show that structures behind very permeable insulation can wet up. The question, therefore, is that if you're using something like a timber fiber board as your insulation material, you know that by its design, and it's sold as a vapor permeable material, does that result potentially in moisture buildup behind the insulation. And my assertion is that it can. The other issue is like joist pockets. If you try to work up to a timber joist pocket, you've got a cold bridge, and this is an issue now with a cold bridge with a piece of wood shoved in it. And so actually thinking about the mechanics and the design is really, really important with internal wall insulation. But it's not me saying it's bad. It's just it can be bad. It can be dangerous. And understanding moisture risk with all forms of retrofit insulation is very important. It's understood, I think, but there are an awful lot of people out there in the world thinking and working on these problems right now.
Okay. Going back to moisture meters then, a question was raised. Obviously with Protometer, you get a conversion chart for when using them for use on masonries. What's your thoughts on that? Should they be used? Are they accurate?
Conversion charts. Oh, well, lovely. Yeah. What have you ever read one? and when was the last time you took the conversion chart right out the back of your Protometer packet and read it when you're looking at the difference between one form of plaster and another form of plaster? Unless you know what the density or the weight and the porosity of the plaster is, your conversion charts isn't much good. Unless you understand the porosity, the density of a brick that you're trying to scratch on the surface, it won't give you an accurate answer. To me, to be blunt, and I apologize to anybody who out there that manufactures conductivity meters, or what's the point in doing that? Sell them as a diagnostic aid, maybe a quantitative tool for timber, but they're not a quantitative meter for masonry. They're an excellent tool for telling you when something's dry. They're a lousy tool for telling you how wet something is.
This is a bit on remediation, but I think a question we'll touch on. Someone's asked about the Shriver system, and do you believe it works? Or,
no, it's crap.
There we are. Answered that.
No, it can't work. And you know, there is some stuff out there that kind of raises these things, but actually think about it logically. I've seen that product sold as a remedy for condensation. And how on earth are you going to remediate condensation on the inside of a building if you chop a small hole on the outside wall? It doesn't make sense. All you're going to do is create a series of cold spots behind the vent box. And as far as drying out masonry, yes, it probably does have some effect on drying out masonry around that box until the box gets full of salt and it can't work anymore. But the fact is that actually, you know, so would just removing every fourth brick. Why you would have to invest in a terracotta lump that looks awful on the outside of your building to do what you could do by just hacking every fourth brick out of the wall is slightly beyond me. I'd make absolutely no apologies to Mr. Shriver if he's listening. I expect the writ to come through any day, but I'd happily defend myself.
Okay. Getting to the last few, I think. We use damp meters for guidance only. Is it necessary to have them annually calibrated?
No, not really. Just to give you not conductivity meters. No, not really. I've never had one calibrated. Yes, you can use your little calibration thing to see if it still works. That comes with each thing, but generally I haven't ever had one calibrated. What was quite interesting is that either Lidl or Aldi did some damp meters a few years ago, and a colleague, Jervis Sawyer, bought a few and had a test with them and had a play with them, and I bought a couple as well, and we did some comparative tests. And a damp meter for less than a tenner was actually pretty accurate, and was actually in many respects as useful as a scanning tool as my £450 moisture meter. Yes, all right, my £450 moisture meter also does some other interesting things. It's got a scan mode on it, and it's got the ability to air sample as well. So I wouldn't swap it. But the fact is that actually, if you are simply using it to differentiate areas of low and high resistance, then actually it doesn't matter too much as to how accurate it is. If you get rid of the idea that you're going to write down the results from the screen of your conductivity meter and drop those into the report, because if you do, it makes you look like a plonker if somebody like me gets hold of it, to tell you the number of times I've read in reports that the moisture meter says that the wall content is 21% moisture. Well, if you take a brick and you make it 21% moisture, then essentially you've got a bucket of mud. It's unless you've got an incredibly porous brick. It's understanding that there is moisture differentiation that's important, not really understanding that there's differentiation that could be caused by excessive moisture that's important. Not necessarily taking the reading on the moisture meter as gospel that is the percentage moisture content of that sample. As I say, I qualify this again and again and again. It's not quite the same with wood. They can be very accurate in timber, and actually if you're in a lumber yard or if you're looking at quality control in respect to timber, then actually some degree of calibration is probably a good idea. But if you're typically testing the bottom of a wall and jabbing it into plaster, then it's probably, as long as it works, it's probably okay.
I think, well, we're a minute to 10, so we're probably there. The questions we've had a few on remediation, but I think that's probably best left for.
Well, the fact is, if people, I'm never quite sure about how these things look from the other side. It does feel like a bit of a private ramble from this end. But if people are really interested in remediation strategies and how you consider remediation and what good looks like by way of the decision tree with repairs, then that could be potentially another presentation. We could also do something much more detailed on detailed damp diagnostics and evaluation, particularly around the air moisture stuff, if people want that. So send James an email, let us know, give us some indication, and we can do all sorts of things if people want to see it.
Well, folks, you heard that there. Just to kind of wrap up, if there is stuff that you are interested in, whether it be damp or any other kind of subject that's within our field of specialism, certainly feel free to kind of ping us a wee email over. Guys, just to kind of wrap this up just a little bit, many thanks, James, for kind of leading that through kind of question-wise. You saw it from yourself just at the end of Steve's presentation there. There is areas which, if you do want some additional information, feel free to visit our technical document library. The link is on the screen there. You'll find a whole variety of damp-related guidance, best practice, etc. within there. Also, you can visit our professional section as well. You'll find a whole variety of other information. We also, as well, once the training when we do finally get our training back up and running, we do have a variety of training courses for surveyors, technicians, and also a whole variety of kind of subjects that are damp related as well. The links are on the screen there. It's just property-care.org/training. In terms of this webinar as well, we will have the recording available for everyone early next week, probably on Monday, and I will push it out to all of our attendees, and you can pass that out to your colleagues and anyone else that you think might be of interest to. Just to kind of let you know as well, if you tuned in at the very beginning, you would have heard that our professional CPD series is continuing. Next week, we have the next in our CPD webinars, Waterproofing and Insurance, Design with Confidence, which is being headed up by Michael Earl. After that, on the 21st, we have our next in our invasive weed CPD webinars, Under the Radar, Bud Layer and Bamboo. Also, as well, for all of our PCA members, you heard me say it at the start, tune in Tuesday. This is your platform. It's the place in which you can get updates on what's been actually happening, especially during COVID-19. And if you do have issues or problems, it's a place in which you can try and pose those questions to us. And if we can help, we will. The web address to sign up for all that is just on the screen there. It's just property-care.org/webinars. Guy,
Okay, well, listen, thank you everybody. From my perspective, it's great to have had such a big audience. Nobody's sent a message yet from Frank Shrivers, so you know, maybe I'm going to go and hide for the rest of the day and pretend I didn't say what I said quite so publicly. But it'd be great to see you again. Yeah, follow me on LinkedIn if you want to see more interesting pictures from time to time. But thank you all. I'm away. Cheers.
thank you, everyone.